Hello and welcome to CP Algebra 2B. This is section 6.1. What we're learning today in our essential question is, what is the relationship between nth roots and rational exponents? As we move into this chapter, it's going to be very important that you remember some old things about square roots. And square roots, what I mean by that, taking things like, what is the square root of 36? Well, hopefully you remember that is 6. If you had the square root of 24, how you break that up is it is thought of as the square root of 4 and also the square root of 6, which breaks into 2 roots of 6. So you can use that. Basically, know all of your square roots up to probably like 144, 12 squared, and we can go through there. Some vocabulary to know, nth root of a, okay, so this is what we're going to start to get to know a little better here. Okay, we call n the index. We'll get to that in a little bit. That's the index of the radical, and what's on the inside is the radical. Now, a rational exponent, okay, what's kind of neat here is this is the same thing as n roots of a. Okay, we can think of the n as a little fraction 1 over n. And then if you were to rewrite, you can also think of it as n roots of a to the m. So if you have a fraction here, that's really the same thing also as n roots of a raised to the m power. Okay, so n is always the denominator of the fraction, and m is the numerator if you have something like that. Okay, anyway, some examples here. So you will be asked to do these. You should be able to do so with a calculator, but if you use one, that's really okay. But for something like 16 to the 3 halves, okay, how we can rewrite that then is it would be the same as, so 2 is going to be our index, and then 16, and then to the 3rd. Okay, now some things that you know about this is really if we take the square root of 16, that is really 4 to the 3rd, and 4 to the 3rd is 64. So it's kind of just rewriting some things and going from there. 125 to the 2/3. 125 to the 2/3 is the same then as the cubic root of 125 squared. Okay, you can take the cubic root of 125 first, which is just 5, and then the squared, which means it's 25. Another example, here we'll deal with some negatives. So 32 to the negative 3/5. Here's where it gets a little interesting. With the negative, that's going to tell us we have a fraction. So it's 1 over, and then everything else is the same. 5 roots of 32 to the 3rd. So negative means fraction. Okay, from there, just take 1 over the 5th root of 32 is 2, and then to the 3rd, and we have 1 over 8. Okay, let's do some more examples here. Examples always help, especially with these problems. 8 to the negative 4/3. 8 to the negative 4/3. Again, that means it's 1 over the cubic root of 8 to the 4th. Okay, from there, that's 1 over 2 to the 4th, or 1 over 16. So they're really not too hard to do by hand. 81 to the 3/4. Let's check this one out. So in this case, it is really the cubic, or the 4th root of 81 to the 3rd. What times itself? 4 times is 81. Well, that's actually 3. So we have 3 to the 3rd. Okay, and that is 27. Okay, And lastly here, let's do 4 to the negative 5 halves. Negative means fraction, so 1 over 4 the square root to the 5th is 1 over 2 to the 5th, which is 1 over 32. All right. Now there are ways to use your calculator for these, so hopefully you have a graphing calculator at home. If not, whatever you have, but these are the best options to have. Approximate using a calculator, round to the nearest hundredth when appropriate. Basically, if you have a calculator here, you're typing in 9, 2, so a little caret, and then I like to always put my exponents in parentheses. So I'll give you the example here. 9 to the 1/5. Let's say we wanted to take that one. You do 9, you hit the little caret button, and then I like to put in parentheses the 1/5. 1 divided by 5, end parentheses, hit enter, and then you get equals 1.55. We're going to round to the nearest hundredth, so 1.55 works, and that's approximately. Let's try out 4 7/3. Okay, it's easiest to rewrite this as a rational exponent. So we know that this is going to be 7, 3, and again the index is always the denominator. So 7 to the 3/4 is 7 caret 3 divided by 4, and that's 4, approximately 4.30 that one. 64 to the negative 2/3. Let's try this. So 64 to the negative 2/3. Again, this is going to just be 64 caret negative 2/3. Hit enter, and you get 0.0625, or since we're doing nearest hundredth, just 0.06. And then lastly, 5 square roots of 11 to the 4th. Let's just rewrite this as a rational, so 4/5, and just type that in, 11 to the 4 divided by 5, and we have approximately 6.81. So you can also use your calculator to solve these here. Sometimes I want an exact answer, other times not. Some things to take away from here as well: real nth root equations. Okay, so n, if n is an even integer, so our index. Okay, if our index is even, here's what we know. So for even and odd numbers, so let's say for example we have is x equal to the 4th root of a negative number. Well, if x is even and a, this number inside, is positive, we cannot solve for a negative. And you can actually try that in your calculator. If you try and take the square root of a negative number, okay, it's going to yell at you, non-real answers. So there are no real roots. Now, let's say that it is odd. So let's say we want to find the 3rd root of negative 16. Okay, in this place, it actually is possible. So if you try and type that one into your calculator, let's actually go with, instead of 16, sorry, let's go with 8. Okay, this one you can think of as negative 2 times negative 2 times negative 2, which means that x equals negative 2, and it is possible. There's one real root. Okay, so negative numbers with odd indexes, it is possible. Negative numbers with even indexes, it is not possible. Now what if it is equal to 0? So let's say x is equal to the 6th root of 0. Well, in that case we have one real root, which is just 0. Similarly, this works as well for 5. If you take the 5th root of 0, well, 0 times itself 5 times, you have one real root, and that's x equals 0. The last thing to notice here, so let's say if our index is again even, and we want to take the square root or the fourth root of positive 16. This one exists, okay, because we have positive. So if we were to think of 16 to the 1/4, you get 2. And it is positive or negative 2. Okay, there are 2 real roots. So square roots of evens, you always have to think plus or minus. On the other hand, if you have the cubic root of, we'll say 8, and it's positive, in this case it's just going to be 2 and 1 real root. It's a little tricky with all these things here. Just kind of keep this handy. Okay, negative number, even index, no real roots, not possible, and so forth. Okay, some examples. So determining if you can take the cubic root or not. So let's say is x equal to the cubic root of negative 64. We have a negative number, but an odd exponent. So this is possible. Cubic root would be negative 4. Let's try the 10th root of 1. 10th root of 1, even, and so forth. That's just going to be 1 times itself. Now, again, this is positive, and this is even. So this is going to be plus or minus 1. Can x be the 4th root of negative 81? We cannot have an even and an odd, so no real roots. X is equal to the 15th root of 1. Okay, even exponent, odd number, or odd index, sorry, and an odd number, or greater than 0, we would have just x equals 1. Okay, using this trick up here. Okay, and then let's go from there. So just a few more examples. Let's say x is the 4th root of 256. This one is possible, so it's going to be plus or minus 4. If we have the 5th root of negative 32, okay, odd, less than 0, x is just going to be negative 2. If we have the 7th root of 0, it's just always going to be 0. And if we had the square root of negative 25, well, I know the square root of positive 25 is 5, but we cannot take square roots of negatives, so there's no real roots. Okay. Now, the last little challenges here are solving. Okay. You can use a calculator for these, but they'll only give an answer if it is an even root. So let's just go through some examples. Basically, if we had to find x to the 4th is equal to 625, in order to get rid of the 4th root, you're going to cubic root each side. So really, and that just means take the 4th root of 625. You can also think of that as 625 to the 1/4. And in that case, you have x is equal to plus or minus 5. Plus or minus, just remember those. 2x to the 6th is equal to 1458. Here, divide by 2 first. We want to get the x to the 6th by itself. That makes it x to the 6th is equal to 729. Take the 6th root. And if you do that, you have x is equal to plus or minus 3. Another example, negative 6x to the 3rd is equal to 384. Divide by negative 6. negative 64 is equal to x to the third cubic root, which it is possible because we have a negative. It will just be negative 4 then, a single one for our answer. 4x to the fifth. Let's say it's equal to 128. Divide by 4, divide by 4. X to the fifth would then be 32. Fifth root. So you can also think of it as taking the 1/5. Okay, because that's kind of what's happening here. If you take the 1/5 of this and divide by 5, cancels out, then you get just 2 for your answer there. Here's ones where you will get a little decimal answer. Also just good to know. So let's say we had x plus 4 to the third, and that's equal to 12. Here x is in parentheses. So we will take the cubic root first. So we would actually have x plus 4 is equal to 12, cubic root of 12. The cubic root of 12 is not a perfect number. So if you type that into your calculator, so if we do 12 to the 1/3, you end up with 2.29. And then to solve for x, you're going to subtract 4. Okay, so you can do x equals 2.29 minus 4, and you get negative 1.71 as your answer. Same idea. X minus 3 to the fourth is 21. Let's take the fourth root of 21 first. That means x minus 3 is approximately, you can even leave it as an exact answer. Okay, so the fourth root of 21, because you get a decimal. That just means if you add 3 over, x is 3 plus or minus the fourth root of 21. It's really plus or minus. X minus 4 to the fourth is negative 26. Again, negative 26, the fourth root. That is not possible. Okay, so x minus 4. So a little trick question here. Again, can have even and negative. So there are no solutions. No real roots. In an example here, let's say we had x minus 5, okay, squared all over, say, 3, and we set that equal to negative 10. Our first step would be multiply by 3. Let's multiply both sides by 3. So we have negative 30 is equal to x minus 5 squared. Try and take the square root next. Square root of negative 30 is equal to x minus 5. Again, a trap can have even and negatives, so there are no real answers or roots. Okay, applications. They're really not bad. Okay. Basically for this we are going to be using some models they give us and just solving. So population of a certain animal species after T months can be modeled by P. The population is equal to C times 1.21 T over 3. And C is the initial population. Find the population after 19 months if the initial population was 75. So the population would then be 75. That's what C is. 1.21. And then T is going to be 19 over 3. You can really type this whole thing right into your calculator. 75 times 1.21 to the 19 thirds Hit enter, and you get approximately that the population is about 250.8. You would round up to 251. All right, and the study determined that the weight in grams of a coral cod near Palawan Island in the Philippines can be approximated using the model W equals 0.0167 L to the third. L is a coral cod's length in centimeters. So this one here, now let's just be careful. So we are actually given their weight. So we have 200 is equal to 0.0167 L to the third. So we're given the weight, and we want to find the length. So we'll divide each side first by 0.167. That gives us approximately, well, if we actually just keep that in our calculators, so 200 divided by 0.0167, we know that's L to the third. And then we can actually take the cubic root or raise that to the 1/3 power at the same time. And I'll show you what that looks like in the calculator. 200 divided by 0.0167 to the 1/3. We get approximately 22.87 or 23 centimeters. Okay, so those are the notes for the first lesson, 6.1. There are homework problems that follow. Do your best, and thanks for watching. Good stuff.